Hi, my name is Christopher Schaefer, and in this video, I will explain the basics of IP addressing and subnetting. Okay, let's start with IP addresses. When a new device is added to a network, it needs to be assigned an IP address, so it can be identified and communicate with other devices on the computer network. Each IP address is made up of 4 numbers called octets that can be represented as 8 binary bits or a base 10 number from 0 to 2 to the 8th or 255. IP addresses are divided into 2 parts. You can imagine these parts separated by a dividing line. The part on the left identifies the network the device is connected to, and the part on the right identifies the specific device as a host within the network. By changing which bits the dividing line is between, you can change which bits identify the network and which bits identify the host. Moving the line between the different octets reveal the different classes of networks. Placing the line between the first and second octet gives you Class A network. Placing the line between the second and third octets gives you the Class B network. And placing the line between the third and fourth octet gives you the Class C network. Using the network ID, there are 128 possible Class A network addresses, and the host ID allows for 16,777,214 possible hosts on each of these networks. The larger network ID for Class B networks gives 16,384 possible Class B networks, with 65,534 possible hosts on each network. And the even larger network ID for the Class C networks allows for 2,097,152 possible Class C networks with 254 possible hosts on each. Dividing networks into classes organizes all available IP addresses into categories based on network size. When designing a network, the class of the IP addresses available determines the size of the network. Classes, though, are very broad and less manageable. This is why subnetting comes into play. A subnet can be thought of as a room in a house where the house is a network. Though everything within the walls and under the roof exists in the house, the space is divided into rooms so it can be made better use of. Each room is more easily managed and given a specific purpose, as well as offering privacy and separation of unnecessary traffic. Subnets are created when the dividing line between the network ID and host ID is moved within the 4 octets. So if bits from the host ID become bits in the network ID, how then can we tell which bits belong to the network and which ones belong to the host? Suppose we are given the IP 194.225.121.65. In order to draw our dividing line, we need a subnet mask. A subnet mask is a group of 4 octet numbers with consecutive ones identifying subnet bits, followed by a group of consecutive zeros identifying host bits. Using the subnet mask, we can draw the dividing line where the ones end and the zeros begin. Masking the 1 bit over the given IP address reveals the IP address of the subnet, while the remaining 6 bits on the right give us our host ID. The /26 following the IP subnet is the extended network prefix length and denotes how many consecutive ones exist in the subnet mask. Adjusting the subnet mask allows us to create network addresses that best fit our specific needs. For example, if we have the Class C network IP 222.123.69.0 and we would like to use this network for 4 separate departments of a company, we can manipulate our subnet mask in order to create a subnet for each department. By delegating the first 2 bits from the host ID to the subnet address, we have turned our large Class C network into 4 different subnets. I hope this video has helped you better understand IP addressing and subnetting. Thanks for watching, and if you have any questions, you can leave them in the comments below.